Well, I'm going to talk to you about some things that were already mentioned before. I'm going to talk to you about the simulation, which was mentioned just a few minutes ago, but also about operators, about Lean. So we are going to put together some things here in this topic, simulation in Lean 4.0. And I want to give it to you an insight about the topic or the project that we have developed with a company there in Spain. It's a real case of flexible assembly lines for high mix, low volume demand, which is something more and more usual nowadays. This is the outline of the presentation, so let me go directly to the background. We have this traditional dichotomy between productivity and flexibility. So we are very used to this. If we have an automatic assembly, then we'll get very high productivity, but if we need to change something, the flexibility will be really low. But if we move to the other part, the manual assembly, we have just the opposite. So if we can bridge this gap somehow, we can get this. This is what we call assembly 4.0, not only we, but usually it's called like that. With this, we gain flexibility and productivity at the same time. And this is where Digiman or Industry 4.0 can give some very interesting solutions. And I want to mention also this. We have been talking about this 4.0 all the time, but as we noticed from real cases in industry, we could directly say that if the manufacturing system is poorly conceived, digitalization will only be able to optimize a bad design. So what we are saying actually is that before applying these methodologies and techniques, we should probably take care of the production type. If we are applying Lean, we should apply Lean really well before introducing these digitalization tools. And this is what we also saw in our case. This is the study case. We have been collaborating with this company, BSH Home Appliances from the Bosch group there in Spain. And what we have is these gas cooktops, and there are many different models, many different dimensions, materials, and so on. So they are produced, some of them in an automatic line, but the rest of them in a manual or several manual lines. This is what we really have. These are product lines. We have 3 product lines that are, well, more or less automatic, but the rest of them, product line 4, 5, 6, and 7, they cannot be produced in an automatic way right now. If we look into the lines, into those of 2 of those lines, we get that the product families have the same behavior. So some of them could be a little bit more automatic than others. So this is the situation that we have in this company. High mix, low volume demand. What we did was to develop different models to simulate this and to try to find a solution that could obtain this semi-automatic solution. So we developed the models, we introduced design parameters, fixed parameters, and more important, very much disturbances. That's really important. And with that, we obtained KPIs. We started with the first 2 ideas that the company already had. This is a semi-automatic line, and this is a manual assembly line. So this was our starting point. And we also used something similar to OEE that was also mentioned before. In order to establish those KPIs and all those parameters that we needed, first we started with a parametric model with all the equations. We modeled everything with equations using MATLAB in order to get some preliminary results. We also use this model, very similar to OEE, I was saying before. From the available time, we get the production time, and by removing the losses, the manufacturing losses, then we can get the real productive time. With all that together, we made this first model, which was good. I'm telling you a little bit more about this model in a few minutes, but there is a main limitation, variability. We cannot introduce there variability in an easy way. or not in a realistic way with all those equations. So we also developed this other model. This is, well, not so straightforward. You have to spend some more time to create a model, but it gives you the possibility to introduce this variability. This is a discrete event simulation model. We use FlexSim, which is a software, a commercial software that you can use. And well, we can introduce disturbances here because we can introduce variability. And we could also introduce this detailed operator stations interaction, because what we are proposing here, we were together with the company to make this proposal, is not a fixed semi-automatic line, but two parallel lines, two parallel assembly lines with workers walking along the lines and with some shared automatic stations between the two lines. So in this case, we could produce a model in one of the lines, a different model in the other one, or we could produce the same model in both lines. And we analyze many different parameters to get to this solution. Let me show you a video. It will be much easier to understand. So you can see that the workers are like moving and taking the product and moving the product to the next station. Sometimes the station is a shared automatic station. Sometimes it's just the next station. And when the worker finishes, then he goes back. Okay? So we have some advantages here. Of course, we have also some drawbacks with this model. But the important thing is that we use this simulation model to really get the results, what we could expect from this new line. So the parametric model, the first one. First, with this, we obtain the most critical factors. We use a design of experiments because we had many different possibilities, many different factors, number of operators, change over time, etc. We introduced that in MATLAB and we obtained different KPIs. Well, we made this design of experiments in two different steps to get the most influent parameters. We also validated this model and also the discrete event model with real data from the company. We took 1 month of production from the company and we introduced all those data. And well, with these design parameters, fixed parameters, and in the discrete event model, the disturbances, we evaluated that for the actual lines, not for the new one, not yet. And we obtained different KPIs. With this, we made our decisions and we proposed the parallel workers assembly lines. We also evaluated that and we obtained different KPIs. I can tell you that with this kind of line, we can increase productivity up to a 30% compared to the manual assembly line. Of course, with semi-automatic lines, assembly lines, we could also increase productivity, but not that much. And especially if we want to reduce the batch size, which is something very interesting for high mix or volume, we can do it much better with this solution. Of course, there are some drawbacks. It occupies more space, the lead time is not as good as before, and, well, workers have to walk, which is something, and have to be trained to be in all the stations. So you need to find the balance here. But if you apply other of the Industry 4.0 techniques, like augmented reality or cobots, etc., then you can compensate a little bit those drawbacks. And we applied this simulation to many different scenarios in order to get a real result close to reality. And finally, we made a final case study because this was only for the assembly line, but we could also, and we simulated the logistics, the internal logistics. We simulated the mill runs, and we simulated how to feed the lines, and so on. So with this tool, you can do it very easily. You need to prepare the model, but then you can introduce many things there. And this is what we did in this case. So in conclusion, I showed it at the beginning. the mass customization assembly needs operational excellence. It needs a good application of Lean or whatever the technique that you are using. We also analyze the performance of two assembly lines with a parametric model and a discretable simulation model. And with these cases that we studied, we obtained the most critical factors in performance. We also could introduce disturbances, and we validated and made the verification of both tools. And well, we presented these parallel working worker semi-automatic assembly lines that I must say that is very interesting for the company, and it's not implemented yet, but they are finding a way to implement these parallel working worker lines with a good training of the operators, because human factor, even in Industry 4.0, is going to be the key for everything. So this is it. I want to thank especially to Adrian Miqueo, because his work is part of his PhD thesis. He's one of the ESRs that successfully finished his PhD thesis. Thank you.